I'm Jeremy Bowman, a Senior Manager of Software Engineering at 2U. And today, we'll be talking to you about improving open edX maintenance, automation, and crowdsourcing. So first, a little bit more about myself. I manage two software architecture squads at 2U focused on open edX and edX.org. And I've been in this role for a couple of years, and as a senior engineer for a few years before that. So I've been dealing with software maintenance in the open edX space for a little while now. First, I'm going to talk about what exactly is maintenance and how much effort does it take, and how are we reducing that amount of effort through automation and other means. How are we distributing that effort more effectively via crowdsourcing to sets of people that I'll talk about in that segment? And are there ways we could be doing this even better than we are currently? So first of all, what exactly is maintenance? Maintenance is the ongoing work needed just to keep the software usable. So these are bug reports and security issues that come in for the open edX code itself, bug fixes and security patches that come in dependencies of open edX, code that we didn't write and we don't maintain, but we do depend on for the services to work correctly, so we need to keep them up to date. Breaking changes in dependencies that require modifications in our code in order to get onto the latest version, which is often important because then we can't, without making those changes, we can't get onto a new version that may have a security patch later down the line. We don't want to have to rush and do all that work while we're also trying to quickly patch the software. Also, some dependencies get abandoned over time, and nobody's looking for security problems in them anymore, except for potentially like black hat hackers. And these are things that we need to either fork and maintain ourselves or like migrate off to a different solution. Major upgrades before the end of support windows. Many of the bigger components in open edX, like that is built on top of, such as Ubuntu and Django and Python, have support windows for each release during which they promise to release any security patches and such that come along. And we want to make sure that we're onto the new version before that window expires, so that if any issues come up, we're ready to install the latest patches. And we use various development services and templates, and these get modified over time, and we want to keep up. If there's major problems in our continuous integration system where it changes how things operate, we need to change to make sure that our tests continue to run. If the template that we created a repository from makes some changes because we find out there's a better way of doing things, we like to make sure that all of the services derived from it catch up and apply that change as well. So some examples of maintenance work. A security researcher might reach out to the security mailing list for open edX to report that they found something they think is a vulnerability, and then we need to take time to investigate and potentially address it. Django 3.2.13 is released and fixes 2 SQL injection vulnerabilities. We may know that there's a release coming, but until the day it's released, we don't know about it. We need to get this out the door fairly quickly to make sure everything stays on versions that aren't going to be subject to security attacks. Celery 5.0 is released with breaking changes, and as of that release, earlier versions will no longer be getting any security patches. So that's an example of the breaking changes that we need to not necessarily drop everything and upgrade, but relatively soon we need to apply that. Django OAuth 2 provider is abandoned, forcing us to switch to Django OAuth 2 another real example, though from a few years ago. This took a fair bit of work to completely switch over the core of our authentication system. Support for the version of Node.js currently in use ends within a month. This is a very timely example. This is happening right now. We're switching from Node 12 to Node 16 because Node 12 reaches end of life at the end of April. And another real example, Travis CI reliability and cost become unacceptable after an acquisition, forcing a migration to GitHub Actions if we want to be able to keep running our tests. These are all things we've had to do. So how much effort does all of this take? Well, here's some recent estimates based on our experience. For a small microservice, we expect maintenance work to take the effort of one developer for about 10 weeks per year. For a Python library, maybe 7 weeks a year. For a micro frontend, 5 weeks a year. JavaScript library, maybe 4 weeks a year. And for a much larger batch of Python code, say a large library or a very large service, each additional chunk of that, that's about 150 kilobytes in size worth, would take maybe an extra 5 to 6 weeks per year. So that's like maybe a little higher than I expect, but doesn't seem too bad. Where does that 200 kilobytes for the microservice number, where does that time for the 200 kilobyte microservice come from? well, say 3 days per year of upgrading Django, because we need to do this about every 2 years. 2 days per year for Python upgrade. Python 2 to 3 one is particularly bad. Most are a little easier than that. Monitoring for breakage, 2 days a year if we spot something unusual and have to go and investigate it. Automated pull requests for JavaScript dependency updates makes maybe 2 weeks per year. Most of the time it's just, yeah, we upgraded, test passed, merge. But if something unusual happens, there's a breaking change in the library, we have to go in and fix it. Similarly for Python dependency updates, again, about 2 weeks per year. Tests sometimes fail only occasionally. When that happens, we need to take some time and figure out what happened and why and fix it. This takes like a day a year. Deployment pipeline maintenance and troubleshooting, another week per year. Review of submitted code contributions from people who we don't employ, but have said, hey, I think this would be a nice addition. Can you please take a look at it? Maybe 2 weeks per year to take a look at those as they come in. Responding to security issues reported 2 days per year. Writing and updating documentation, 1 day per year. And accessibility fixes. This is important in order to maintain our WCAG 2.1 AA scoring. Day per year on that. And changes in CI and release tooling. This takes about a week per year. So, okay, that's reasonable. Like some of those numbers you can say, well, maybe we could bring that down a little bit, but overall it doesn't sound that bad, but that's for one service. Then multiply that by, there are about 14 services currently in Open edX. Now you're looking at 140 weeks a year just for the services, and that's assuming they're all 200 kilobyte microservices, which is definitely not the case for things like edX platform. There are more than 80 Python packages in the Open edX ecosystem. That's looking like 560 weeks a year. There are 20 MFEs, there's 100 weeks a year, 20 JavaScript libraries, another 80 weeks per year. We're already at about 18 full-time developers, and we haven't even factored in the fact that edX platform is not 200 kilobytes of code, it's 600,000 lines of Python code and almost as much JavaScript. So really, maintenance accounts for about half of the development effort undertaken at 2U with respect to edX.org and Open edX. And other members of the community help out as well anytime, especially one of the big upgrade efforts comes along, and they maintain many of the libraries used in Open edX. So this is a non-trivial chunk of work, and any gains we could get here in shaving this down a bit would really help us spend more time working on new features and improvements to the learning experience and other things that we care about for the people who are using our software. Is this unusually high for this kind of project? Well, Python and JavaScript systems have a baseline level of breaking changes. They allow for the fact that it's okay to make a change that breaks backwards compatibility in order to keep adding new features and keep the design clean and let the project evolve over time. Some other languages, such as Java, tend to have fewer such breaking changes, but the trade-off there is that the language and the libraries tend to get very static over time. They become very fragile, and someone comes along with something better and just replaces it outright. So things change all the time in software development, usually for the better. You look at a new Django release, and most of the things in there are things that are like unquestionably an improvement over what was there before and really help out new development and new developers. And so to some extent, this is the cost of keeping up with the ecosystem and keeping software competitive and secure over time. But we can do some things to get more efficient at keeping up with this process. So how are we reducing the effort? A number of years ago, we tended to postpone upgrades until absolutely necessary, figuring this would save the amount of overall effort if we only upgrade what we have to. But that turned out to be a time bomb for security problems and things reaching end of life, because there are long chains of dependencies, and needing to apply a security patch in a particular library could suddenly force us to update 20 or more dependencies, some of which have breaking changes, and it could take weeks just to apply a simple security patch. There's as well a 6-month support window for stable Open edX releases. So we need to get these done. So if one of the security issues comes up during the support window and the software was already out of date, so you have to make a lot of changes in something that's considered a stable release, and you're trying not to change it very much. It's much better if it was mostly current and you could only have to update 1 or 2 things when you do need to make a change. So we've stopped doing this for the most part. Now we have systems to automatically generate pull requests for small batches of updates. For Python, we have a GitHub action template that runs this using pip compile. For JavaScript, we use a service called Renovate. And we automatically get these pull requests in on a daily or weekly basis saying like, hey, these few libraries have updated, try the new version. It automatically runs the test. If they pass, we usually just merge and move on. Problems tend to be small because you've only upgraded 1 or 2 things at a time. It's easier to diagnose than if you tried upgrading 20 things and something broke. You have to figure out which change broke it. And sometimes we do have to postpone changes that come in these pull requests. It's like, okay, that broke something. I'm in the middle of something else. I can't fix it right now. So I'll pin that version, but we make it a point to come back frequently and try to address those before a security patch or other upgrade may be required. Now, we've also started using scripts to do code refactoring. These are called codemods, named after a certain Facebook project. For Django deprecations, we started writing these ourselves using a framework called Bowler. Now there are 2 packages that are being externally maintained called Django Codemod and Django Upgrade that try to write scripts to automatically transform your Django using code to a version that will work with the new version without breaking compatibility with the old one. And this dramatically reduces the amount of effort to go through and fix everything that's been changed there. Now, notice this is for Django. It'd be nice if they had this for other libraries and for the Python language itself, but that's something where the community is still starting to develop some traction. We wrote scripts to automatically update tox.ini and the GitHub action workflow configuration. You can find these tools in the URL here, and here's an example of the kind of changes you need to make to a configuration file. Here we just added testing for Django 3.1 and Django 3.2, where previously CI wasn't running it. And this, we basically, when we're going to new version of Python or Django or such, we need to do this in dozens of repositories. It doesn't take that long by hand, but if you have to do that many, it really adds up, and it's best for consistency just to script it. We also, in addition to the automatic pull request generation for dependency updates, we now have the ability to check out an entire list of repositories, run a set of code mods against each of them, create a PR in each of those repositories of all the changes made, automatically trigger the tests, and now we just have to go look at them and decide if the result was okay to merge. And we can do this all from a single Jenkins job. So this, again, has been a big time saver on the last couple of major upgrade projects, and we're still refining it. It'd be nice if we had it run someplace other than Jenkins, where it's a little more accessible. We're still working on that, and at least we have the tool now. We've created some dashboards for tracking where we are on the state of maintenance. There's a repository health dashboard. You can find the starting point for the code edit at this URL. It's open source. You can easily go out and run it yourself. The output is currently private because the version we use internally at 2U contains information about private repositories. We're working with TPRL on seeing if we can get some kind of a public version on this setup in the near future. This makes it easy to find all repositories that have a particular problem, and we can define what kind of things we check for. We basically run what looks like a unit test suite and say, well, does this thing have a license? Is it the license one of the ones that's compatible with us? Has it moved off of Travis CI yet? We can ask all these questions about the repositories and see, okay, well, what's the biggest problem currently, and how many repositories are subject to, and how do we split up that work? For big upgrade projects, we currently make manual wiki tables like the one example here for the Django 3.2 upgrade. This makes it a little easier to do the project management and tracking and know where we are and what the stages are and which stage has been applied in various places. We really have something a little more automated for this, but this is the best we found so far. We have a analyzer for the test suite warnings for edX platform, where there's a bit of a tech debt here. There's like thousands of outstanding warnings that haven't been addressed yet. Most of them are pretty minor. But when things like Django deprecation warning started coming in here, we actually need to fix all of a certain category of warning. It's very hard to go through the output of the test suite on the console, find all of them and fix them. So this helps group them by type and then go in and look, okay, where did each one of these happen? And you can go in and fix all warnings of a particular type, and also gives you a better snapshot of what really is the test suite, where are all those warnings coming from, how much do we need to care about it. We started packaging this up as a package that could be used in other services, and that's still a work in progress. We've got a little more work to do there. So those are some things we're working on the efficiency side of things, but how about the distribution? If it's the same people always doing maintenance effort, it's easy to burn people out. We wanted to spread this around a little more, and there are a lot of sites running OpenEdX around the world. And although we're happy to help it to you, and we have maintained one of the largest sites, edX.org, we'd like to make it possible for other people to help here in ways that are mutually beneficial. So here's some of the things we've tried in that regard. There are hundreds of developers not employed by 2U. There are even more people out in the world not part of the OpenEdX community yet that may be interested in working on it. Students who are looking to get some programming experience, people who are currently job seeking, looking to brush up their resumes and experience a little bit. How can we enable and incentivize these people to help with maintenance? So some things that have been tried. One experiment was the Incremental Improvements project. The idea was like, hey, let's create dozens, maybe hundreds of small tasks needed for a big project, in this case, the upgrade from Python 2 to Python 3. And we'll make it as easy as possible to set up a development environment, follow the instructions, and get started on the task. Allocate time from more experienced developers, people who know the project, to help newcomers, and invite a lot of newcomers to help and take on these small tasks and not only do something to help the project, but get some experience for themselves. And like I said, especially students and job seekers, other people, a lot of welcome the opportunity to get involved and just see what this kind of thing is like and what's involved in it. So this actually worked pretty well. We got a lot of assistance in fixing running scripts and checking the output from tests and verifying things and getting things ready for the Python 3 upgrade. But there were some problems. That code review and assistance that we had to provide took a lot of time. These are people who are new to the project. We had to help them with things beyond just the task at hand, just like how do they set up the development environment. So it's debatable how much time we really saved on it, but it was viewed as a positive thing because we did get some long-term contributors out of the effort. We don't have support for Windows development in OpenEdX for most things, and many random people you pull out of a development community are running Windows, and we really struggled to find ways to get them tasks that their development machine could actually perform. Setting up DevStack was a pretty big obstacle. It took time, and even with optimizations, to make this such that they could do an offline installer and they didn't have to go and download everything from the internet. So even if they're the meetup event we're at or the conference had limited bandwidth, they could install it. It still took easily like half an hour to get everything set up so they could start doing something. And using Jira posed some problems. It's not the most intuitive thing in the world. If you haven't used it before, you need to register for the particular instance, and that caused some roadblocks for people. There was an OUP for this. It's OUP 25. You can go and find it at this URL. This was a good experiment, something we haven't ruled out trying again, but we do want to learn from these lessons and try to do it better the next time. So the next thing we tried is, well, we had problems with newcomers. What about reaching out to just people in the community to help with an upgrade? So we did this for the Django 3.2 upgrade. We created a GitHub project board and asked for people who are already in the OpenEdX community to help us update dependencies of OpenEdX to support the latest version of Django so that it wouldn't pose an obstacle when upgrading our own code. So this meant that because we put it in GitHub project board, we didn't have to deal with Jira. These are people who didn't have to deal with DevStack because these aren't actually OpenEdX code. This is the libraries out in the open source community. Most of these also support whatever operating system, and most of the people participating here aren't on Windows anyway because they're OpenEdX developers. And we didn't have to review the code because these are PRs going into other projects. And we got a fair bit of traction with OpenEdX developers, and again, shaved down some good time on getting this upgrade done. But there are some limitations. We didn't really reach out to new people. It's people who are already doing things to help with the OpenEdX community. We're just asking them to help in a different way. It required a lot of lead time in order to give upstream maintainers a chance to respond and merge the PRs and address any issues and get tests fixed and so forth. We had a good run book for this, but there wasn't much automation for it. For our own code upgrades, we have some scripts for, as I said, updating CI and running codemods and such. It was a little hard to apply that for these external packages. And so it was a little bit of a manual effort for the developers involved. But as I said, it did definitely shave down the time that, calendar time needed to get this upgrade done. Another thing we've tried is making more public working groups for collaboration between 2U and the rest of the OpenEdX community. We've opened up what were internal working groups like deprecation and front-end development to be public working groups with community members also. We have gotten community members to attend some of these meetings that help with assorted tasks. And this makes it easier to coordinate big changes where we need to know, like, how is the community using this thing? Is it okay to kill this off? What do we do about micro front ends? Things like this. But what we haven't gotten out of this so far are direct code changes for doing maintenance. And many of the people who volunteer for these working groups are people who are already doing a lot in the community and don't necessarily have a lot of additional time to spend on it. So the amount that this can actually reduce the amount of maintenance burden at 2U and like things for the community is a little limited. Another option that we've tried a few times is blended development, where 2U or tcrl will pay a development team in the OpenEdX community to help with a specific project and partner with them to get that project done, from the requirements all the way to testing and deployment. So this can have a big impact on targeted areas. We've gotten a number of these successfully now. The incentives are very clear here. People are getting paid to do this. So they will make time to do it somehow. But the limitations here, it's mostly useful for big backlog tasks. For maintenance, like, it helps for the big things that we've been putting off for a long time. It's not so useful for the day-to-day because it still has a fairly high code review and coordination cost. We still have to look at all these changes, make the plans, go through the bidding process, and there's just a lot of overhead making one of these projects happen. So it's useful for a really big project, and not as clear how to use it for smaller day-to-day maintenance tasks. So that's where we are now. We've managed to reduce the effort a fair bit, and we've managed to shorten down the effort somewhat. Can we be doing this even better? One thing we're going to start, we've already been trying to do, we're going to do more of, is planning out our big upgrades much earlier, so that we get a written plan for the next Python, Django, Node, whatever upgrade well in advance, write any automation that's needed for it, and give people a lot of time to work on it. And also try to make sure that we're not trying to upgrade both, say, Node and Ubuntu at the same time. So even if the end of life dates upstream collide, we'll set an artificial one for one of them a little earlier, so we can stagger the completion dates so that there's only one big thing going on at a time if possible. And we don't want to wait until we're doing a major upgrade to deal with the fact that we have some dependencies that have been abandoned upstream. We need to be a little more proactive about this and deal with that when we're not in a rush to get a big upgrade done. It's like, hey, this library is not being maintained anymore. We've got about 12 months before that's a real problem. Let's start now and figure out what to do about it and get that work scheduled. And we plan to capture these upgrades information in the OpenEdX roadmap. There's a link to it here for when you get the slides. Better bundling and packaging of our automation tools. So like I said, we have some code mods. We want to be able to bundle those together so you can say, like, run this entire set of code mods that's needed for this particular project on a repository. And then we can run those on our repositories. We can run them on external repositories in order to generate PRs for external maintainers. And then we can add to that bundle incrementally. So we can say, this is everything we need to do right now to prepare for the eventual Django 4.2 upgrade, but some additional code mods will probably come in later. We can just run it again to get the differences. And so we can do some of the work early and get it started ahead of time and space it out better and be a little less time pressure on it. And we want to package this up for the broader development community and get some help on this. This is something that I think would be useful for other people using Python, JavaScript, Django, et cetera. And as you mentioned earlier, the Django community is already starting to pick up on this a little bit. And we want to work together with the rest of the open source community to make these big upgrades a little bit more efficient. And I mentioned before, we have the warnings analyzer. Would really like to get that packaged up and make it a little easier to use it for the repositories. We would like to maintain a public maintenance backlog. So once we have a little more slack in the schedule that we're starting these things early and we can take some more time on it, we'd like to make a big list of all the things that these need to be done sometime. Can people please chip away at it gradually, incrementally as you have time? We're thinking to tentatively set this up as a GitHub project board. We want to add tasks as soon as we identify the need for it, not waiting until it absolutely has to be done. Link the tasks to the projects there's blocking completion of, so that when it does come closer to the time, or when people are looking like, well, which of these things do I want to start on? Maybe I'll work on the tasks that are blocking the next project to come up so it doesn't become a crisis and we can get this done a little early. And then basically once we have this backlog, then we can direct anyone who wants to help to this backlog. This could be existing community people. This could be newcomers who are looking for like, hey, is there a nice bite-sized task I can do to learn open edX development? We can just throw them all at this backlog and start working on things while they still have some time to like learn the ropes and get used to it and help out. And then once we have this, we can try to think of like, what are the incentives here? Are there any monetary incentives? Do we do badges on discourse? And we can think of different ways to make sure that people have an incentive to help with the collaborative community effort of maintaining open edX, which all of us are using to run these sites and help all these learners around the world. And we'd like to get better at maintaining the effort, distributing the effort done for maintenance and reviewing. Right now, an awful lot of open edX routine maintenance and required reviews is centralized to you, and we'd like this to change. Not just because like we think, oh, we're doing too much work, you guys help out, but also just because like some of these things we're maintaining, but we don't use as actively as other people in the community. Other people are much more invested interest in seeing these projects succeed. We'd like to enable them to make that happen. So we want to move some code that's currently owned to other organizations more vested in those features. Some of these things on the maintenance backlog I'm talking about don't need to be reviewed by someone necessarily at tcrl or to you. They can be reviewed and merged by any core committer who has merge permissions. And if even that ends up being a burden, we don't have enough core committers with time to do the review, maybe we can look at doing something like peer review of new coming contributors to just do a first pass at whether a change looks appropriate, spotting the obvious problems before it then goes to someone with more experience taking their time to do a final review. And there are projects out in the community like Jazz Band and Tidelift for trying to improve the situation around the state of good repair of open source libraries. And there's probably some ways we can leverage them to try to do this a little better. And we're open to further suggestions. So most of the open edX maintenance projects and the improvements of maintenance have so far been driven by like edX and now 2U, but the burden of maintenance work reaches much further. The community gets dragged in every time we need to do major upgrades. It impacts a lot of people, and would really like to make this better for everybody involved. And if you have any ideas on this, on how to do it better, make it less time, how to distribute the effort more effectively, would love to hear about it. And thank you. That's all I have for today. And now we'll go into the Q&A session. And if you're not watching a later recording of this, or you have questions that we didn't get to at the Q&A, you can find me. I'm Jay Bowman on the Open edX Slack. Thank you very much.
So as mentioned, we're going to run a QA session. I will be walking around with the mic, so people who are listening from the Zoom stream will be able to listen in, but James will be fielding the questions. So anyone? Yeah.
I was happy to see that the tools that you're using to maintain the repos are being open sourced and worked on. Do you think that they're actually really useful for repos outside of Open edX, or are they like, oh, there's a camera, hi, or are they very edX specific? Oh, you're muted, Jeremy. Oh, because Braden can hear you.
Braden can hear?
Yeah.
Oh, okay. So he's not muted on his computer, so.
It's this one.
Okay.
Yeah, online can hear you. Maybe it's.
No, he's on. Can you hear? Yeah. I can hear him on Zoom. Okay. So we'll need his Zoom audio for the. Is the volume on Zoom?
Is it working yet?
Hey!
Okay. I was just saying that I actually gave a talk on very similar on a lot of these code mods and automatic refactoring tools at the last US Django Con. And there was a fair bit of interest in people saying that, some of them are doing similar things. Some of them have been wanting to do something like this. And there's definitely some interest in using some of these tools. Like I said, there's those two packages that are now being maintained in the Django community for doing something similar. And some of the things I mentioned about the tox files and the GitHub action workflows and such, there's definitely interest in the community to be able to use those as well.
Anyone else?
So of the initiatives that you tried, the incremental tasks and the community boards and the public working groups and all of that, are there any of those that you're going to be continuing to do? Are you going to discontinue any of them?
So the incremental improvements one has been idle for a little while. Like documentation and such, we came up with that is still up, but we haven't been actively seeking newcomers, partially because the issues I raised with how it was taking up a fair bit of internal time just to get those people ramped up. But it's something we're still like interested in trying again if we resolve some of those problems. I'm hoping that as we get tutors set up and get better instructions in repositories and more standardization around Docker and such, hope we have some quick start documentation in individual repositories, then maybe it'll work a little better the next time around. But the other things were all like continuing through various stages. So like the board we had for the Django upgrade, I'm hoping to set up something very similar, as I mentioned, for just a general maintenance backlog and then just have that be an ongoing thing. That board for the Django upgrade is actually still active. There's still a long tail of work there where dependencies happened to work when we upgrade them, but they're still not officially tested upstream, and would like to get that fixed.
Cool. Hey everybody. Hi Jeremy. One of the questions I had is, and I'm sorry if you mentioned this already in the talk, but do we have a persona for the new Open edX contributors? In the sense of like, who are these people who are joining the Open edX community who are contributing code? Are they people, or I mean, is it a mixed bag? Do we have a certain tendency for them to be of a certain area? I guess in the view of like, helping improve, how we try to attract them to contribute more to Open edX. Thank you.
Yeah, there's not much in the documentation right now targeted to such people. This is something that's being worked on at TQuil right now, is coming up with specific personas for the documentation so we can target documentation better at certain kinds of people. The incremental improvements initiatives was sort of the first effort we had to identify this persona of like, I'm a relatively new developer, or maybe I'm an experienced developer, but I'm new to the Open edX project. What is the bare minimum I need in order to get useful and start doing useful contributions? And it was very informative when we did that, of just where the pain points are, what parts took a long time to set up, and where we were putting people at reams of documentation that they actually only needed to read 5% of for the task at hand. And we've improved things a little bit since then, but there's definitely a lot more we can do that area to make the experience better for these people.
I think that's it. Thank you so much.
Jeremy, thank you.